In this video we're going to be looking at the concept of recursion, and you'll be seeing some practical implementations of recursion just to give you an idea of how it should work. So what is recursion? Well, you can describe a recursive subroutine as something which is defined in terms of itself. That means that it calls itself from within the program code. You can say that recursive subroutines have something called a base case, which is an explicit solution to a recursive function, and a general case, which is the definition of the recursive function in terms of itself, okay, or where the recursive subroutine is called by itself. And that seems a bit difficult to get to grips with. Let's have a look at an example program and see if that makes sense. So in this pseudocode example, we're going to create a procedure called stars, and we're taking in a parameter n, which is a number, and then we're just simply going to output asterisks multiplied by the number of n. So if it's 10, we'll get 10 stars. And then we test n, and we say if n is greater than 10, then if n is greater than 0, then we can call stars again from within itself, but passing to it n minus 1. And then we end if, and then procedure, and then without saying the procedure code or the subroutine code, we call stars with a number to start this recursive process. So this is how it looks in a trace table. So if we start with n being 10 when it was passed in, we output 10 stars. And then we test to see if n is still greater than 0. Well, it is. It's going to do it on the next line down. So then we call stars with n minus 1, and that creates a copy of this procedure in the computer's memory. And so n is now 9. It's going to output 9 stars and test again. 9 is still greater than 0, so we recurse again by calling stars with n minus 1, which is 8, makes another copy, tests, recurses, output, tests, and recurses, outputs, tests, and recurses, and so on until you get down to the n being 0. And when n becomes 0, we output 0 stars, and then we test and see if n is greater than 0. Well, n is not greater than 0, so that fails. And so nothing happens, and then we end the procedure. And when we end the procedure, the program goes back to its previous copy of stars. And in the previous copy of stars, we're at this line of code, and so we end the if, we end the procedure, we go back to the previous copy of stars. So it's like we're going back up the trace table. So n becomes 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10, but nothing happens, and we don't have to trace this, but nothing happens because we're at the end of each of the procedures. And when we finally recurse back to 10, so the stars brackets 10, we're at this point here, that procedure ends, and then we go back to the calling code, and that calling code has nothing else to do, and the program stops. It's maybe quite a hard idea to get around, but just think of every time you call stars, it creates a copy of that procedure in memory, and the previous copy of stars in memory is paused, a bit like a process in the CPU. It's paused at this point here, and when you return to it, it continues execution from that state, from that part onwards. Let's try another example of recursion. Same idea, we're going to print the pyramid of stars, but this time we're going to recurse and then output. So we start with defining the procedure, but the first thing we do is we test to see if n is greater than 0. If it is greater than 0, then we call stars with n minus 1. Then, once that part's finished, we output the number of stars times n. So if it was stars 4, it would output 4 stars. So let's do the trace table for this. What I'm going to do this time is I'm going to add one extra column that just shows the procedure call, so that you can see which copy of stars that I'm currently working in. So we still have output and n greater than 0 as a test, but this time we've got the call number, which is basically n, and then we've got the procedure call, so that you can see if I'm calling stars 4 or stars 3 or stars 2, etc. So to begin with, our call number is call number 1, and the procedure call is stars 4. And so we feed into this procedure and we say if n is greater than 0, well, 4 is greater than 0, so that's true. Then we call stars n minus 1. So that creates call number 2, stars brackets 3, because it was n minus 1. And so in this copy, we test is n greater than 0? Yes, it is. And if it is, we call stars n minus 1. And then stars 1, and then stars 0. At this point, we can say that when star 0 is called, we reach the base case. So the base case is the lowest, or the end function, if you call it, or the end goal. And so n greater than 0 becomes false. And so what happens is that star 0 then continues through the code. It outputs star times 0, so output is still nothing. But we end the procedure and we go back to the previous calling code. Remember, at this point, stars 1 is the output. So n greater than 0 is still true, but now we're at the point where we're outputting the number of stars, and so we output 1 star. And then going back to the previous calling code, we output 2 stars, then 3 stars, and 4 stars. And this part here, I'm going to do in a different colour, this part here is called the recursive calls unwind. And that's where all of the previous calls are completed. So the copies of the procedures, that execution is completed until you get to end procedure. And so it just unwinds the copies of the code that you created in memory.